Hello, in this video we're going to look at how to find the sum of geometric series. So geometric series is when you take the terms of a geometric sequence and add them all together. We're going to look at this in terms of summation notation. So being able to recognize that something in a summation notation is in fact a geometric sequence, and then we can find sum of it. So remember, a geometric sequence, the rule has the form a sub 1 first term times r to the n minus 1 power. So if you notice that what's inside your summation notation has that form, so basically the thing that's going to clue you off is if in the exponent you have an I minus 1. If it's like that, you can use this formula right here to find the sum. So just like with arithmetic series, there's a nice formula, so there is with a geometric series. Okay, so let's put this into practice. In the first one, we have the geometric rule 4 times 0.3 to the I minus 1. And we're finding the sum from 1 to 12. So as the formula says, S sub 12, the partial sum of the first 12 terms, is equal to the first term, which is 4, times, because of the rule, that's the first term, 1 minus the common ratio to the nth power, so that's 12 because we're finding the sum of the first 12 terms, over 1 minus 0.3, 1 minus common ratio. So then we have 4 times, well, we're going to find 0.3 to the 12th power, which is going to be a real small decimal, and we go 1 minus that number, and again, it gives you something really small. It gives you 0.999999486. Okay, give a little curve to that number. And then 1 minus 0.3 is 0.7. So I wrote it out this time, but I would recommend just keeping everything in your calculator because of such small numbers. And that ends up giving me 4 times 1.429. I rounded it a little bit. And then I multiply by 4 to get the sum of the first 12 terms is 5.714. Let's try that out with a second example, see if we get the flow of it. This one, again, we recognize that that right there is a geometric rule, and it's asking us to find the sum of the first 8 terms, and we go first term times 1 minus the common ratio of 3 to the 8th power divided by 1 minus 3. Now 3 to the 8th is 6,561. So 1 minus that is negative 6,560 divided by negative 2, which gives us 3,280. Multiply that by 5, and you get 16,400 for it. So these are the straightforward geometric series when it's in summation notation form like that. But you don't have to do just an finite series. Like this is from 1 to 8, a set amount, 1 to 12. With geometric series, you can also do an infinite, and that's pretty cool. You can add up an infinite number of numbers and get a single number. Let's take a look at that. Okay, so for this example on the right, you see that I'm going and letting n go from 1 to infinity. Add an infinite number of terms. And this is also a geometric rule that you can see. So we're adding an infinite geometric series. Can I do that? Can I get a single number? If the common ratio of r is less than 1, or more specifically, the absolute value of r is less than 1. So r can vary between negative 1 and 1. If it's like that, so in a sense I'm dividing by some number, each term in the sequence gets smaller and smaller, it decreases. If r is there between negative 1 and 1, I can find the sum of an infinite number of things. Let's think about it. Over here, I have our formula that we just talked about for geometric series. What if r is less than 1? What if r is 1/2? If I take 1/2 to the second power, I get 1/4. If I take 1/2 to the third power, I get 1/8. If I take 1/2 to the fourth power, I get 1/16. What do you notice about these values? 0.25, 0.125, and this is 0.0625. They get smaller and smaller. So if I go 1/2 to the 100th power, well, that's going to be 0.0000000. Okay, something really small. If I go 1/2 to infinity, Well, applying a little bit of calculus to it, we can say it is effectively 0. In fact, it's exactly 0. So how does that change our formula? Well, it allows our formula to become this. A sub 1 is equal to 1 minus 0. This term right here, we just discovered is going to go to 0 over 1 minus r. What does that simplify to? Well, a sub 1 times 1 is a sub 1 over 1 minus r. So we can say that the sum from 1 to infinity of a geometric sequence is just a sub 1 divided by 1 minus r. And that's the formula we can use if we're adding up an infinite number. Just remember, in order for this to apply, the common ratio has to be between -1 and 1. All right, let's do 2 quick examples. So we're going from 1 to infinity. I see my common ratio is less than 1. So we can just go, the infinite sum is a sub 1 divided by 1 minus 0.6. So 4 over 0.4. 4 divided by 0.4 is 10. There we go. I think that's really cool. You just added up an infinite number of numbers that quick, and it got an exact value of 10. We can do this without summation notation. Find the sum of the geometric series. Notice the ellipse right here saying it goes on forever. So this is an infinite geometric series. The first term is 12. The common ratio is, well, if we check it, we go 4 divided by 12 is 1/3. So I take the term divided by the previous. So the common ratio is 1/3. So the infinite sum is 12 divided by 1 minus 1/3. So I have 12 over 2/3. 12 divided by 2/3 gives me 18. And that's the sum of all those terms of that geometric series. Just remember, the common ratio has to be between -1 and 1. If it's bigger than that, and it asks you to find the infinite series, it's called divergent. Well, in fact, the sum of them all, it's going to be infinity because each term keeps getting bigger and bigger and bigger because you're multiplying by 2 or 3 or something. So it'd be divergent or not existent.